Hi everybody, it's time for us to take a look at AP Review 7 together. AP Review 7. Excuse me while I hunt around for a marker because I seem to have left my blue one without a cap. So I guess today is going to be... Oh, I found a black one. Okay. AP Review 7, here we go. Problem number 1, let G be continuous such that G of 2 equals 5. Okay. Graph is piecewise linear. G prime is shown on the interval from -3 to 7. Ooh, endpoints are included. Find the x-coordinate of all the points of inflection on the open interval -3 to 7. Justify your answer. Well, this is a graph of G prime, and so I'm going to say that there's an inflection point at x equals 1 and at x equals 4 because G prime goes from increasing to decreasing or decreasing to increasing at these points. Okay, don't say G double prime goes from positive to negative or negative to positive or G double prime changes sign because they gave us a graph of G, not of G double prime. And I'm sorry, they gave us a graph of G prime, not G double prime. And so we need to use G prime in our justification. Okay, part B. Find the absolute max of G on that interval. Okay, so sounds like a candidate's test problem for me. So I know that I know that I have G prime going negative to positive at -1. So there's a min at x equals -1. I see G prime goes from positive to negative at 2. So we have a max at x equals 2. And G prime goes from negative to positive at 6. So we have a min at x equals 6. But we also have some endpoints. The endpoints are included in this problem. And each of the endpoints are minimums. The left endpoint, we start here, and the, G prime is negative, so G is decreasing. So G is decreasing from -3, and we're increasing until we get to x equals 7 on G. So we have maxes at x equals -3 and max at x equals 7. So at the very least, I need to find G of 2, G of -3, and G of 7. Conveniently, this was given to me. G of -3 minus G of 2 will equal the integral from -3 to 2 of G prime dx. So if I add 5 to the value of this integral, I'll get G of -3. All right, let's see what that integral is equal to. We're integrating from -3 to 2. So this has a height of -4 and a base of 2, and we want 1/2 times that, plus this has a base of 1, 2, 3, and a height of 1. And we're looking just for the integral here, right? Just the integral, not the area, just the integral. And so we've got -4 plus 1 is -3. So -3 plus 5 is going to be that G of -3, -3 plus 5 equals 2. And we know that G of 2 is 5. What about G of 7? Well, G of 7 minus G of 2 equals the integral from 2 to 7. Okay, so if I integrate from 2 to 7, there's something wrong in my brain about this. This is flipped. Sorry. There we go. That should be a minus. That should be a minus. This is going to be 8. All right, let's see if we can talk you through that. So I was at 8. I went down -3. So now I'm at 5. And then I went up 1. So now I'm at 6. No, that didn't work. I must have an issue here. Let's check and see. Let's not squeeze things. Okay. So this is what I had written originally. And what I want to say is, hey, that's my B value, that's my A value, so these are in the wrong place. So this should be a 2, and this should be a -3. But I'm not really comfortable integrating backwards, so I'm going to say that g of -3 equals g of 2, and then I'm going to flip these bounds and pull out the negative, minus the integral from -3 to 2 of g prime of x dx. Okay, we know this is 5. And then, what about the integral from -3 to 2? Well, we said the height here was -4, and that's true, and the base is 2, and we need 1/2. So the 2's cancel, leaving us -4. And then over here, there it is, 1/2 base times height. So we've got -4 plus 3/2. Well, that's -8/2 plus 3/2 is going to be -5/2. So we have -5/2. 10/2 minus 5/2, -5/2. 10/2 plus 5/2 is 15/2, or 7/2. So I get g of -3 equals 7/2. Okay, let's try that again. If g is at g is at 7/2 here, 7/2, and then we go down 4, so 7/2 minus 4 is 3/2, and then we go up 1/2, 3/2 plus 1/2 is 5, and so we end up at 5 for x equal to 2. Oh, I love having a way to check my work. Okay, especially on sleepy mornings. So we've got g of 3, and now what about g of 7? G of 7 minus g of 2 equals the integral from 2 to 7 of g prime dx. So now we're integrating from 2 to 7. This is 1, 2, 3, 4 with a height of 2. 1/2, the height is -2 times 4. Plus that area of the little triangle from 6 to 7, which is 1/2, 1 times 1. So this is going to be -4 plus 1/2 is -3/2. So we've got, here's our statement. G of 7 equals g of 2 plus that integral -3/2. G of 2 was 5, and so we get 1/2 or 3/2 for g of 7. Okay, so where's our absolute max? Well, our choices were g of -3 is 7/2, g of 2 is 5, and g of 7 is 3/2. And so this is our absolute max by the candidate's test. Okay, next. Let's take a look at part C. Part C says, what's the average rate of change on G on the interval from -3 to 7? We know that average rate of change is the slope of the secant. 7 minus 3. We know that this part is our integral from -3 to 7. G prime dx. Okay. I think I just erased all those computations, sadly. So the value of this integral, oh wait, I know those values of g of 7 and g of negative 3. I used them in the last problem. G of 7 was 3 halves. G of negative 3 was 7.5, or 15 halves over 10. So we have negative 12 halves over 10, which is negative 6 over 10, or negative 3 fifths. We want negative 3 fifths for part C. Nice. Okay, there's part C, the average rate of change. On G from negative 3 to 7. Okay, part D. D says find the average rate of change on G prime on the integral. Okay, so G prime of 7 minus G prime of negative 3 over 7 minus a negative 3. G prime of 7 is the y value at 7, which is 1. G prime of negative 3 is negative 4 over 10. And so we end up with 5 over 10, or 1 half. And then it says, does the mean value theorem applied on that integral guarantee? And the answer is no, because G prime is not differentiable everywhere on negative 3 to 7. Okay? Great. So, number 2. Okay, 2 says f is twice differentiable on this interval. It is without calculator. F of 1 equals 2. The graph of f prime, the derivative of f is shown. The graph of f prime crosses at negative 1 and positive 3. Horizontal tangent, that means the slope is equal to 0 at 2 on this graph. Write the equation for the line tangent to G. Okay, so G, they tell me, is equal to e to the f of x. And Riley has been telling me all year that in order to write the equation of a tangent line, I need a point and I need a slope. So I need to know what g of 1 is. That's going to be e to the f of 1 power. F of 1 is negative 4, and so I get e to the negative 4. So I have this ordered pair 1, e to the negative 4. And then I also need a slope at that point, g prime of 1. So g prime of 1 is going to be the derivative of g. Let's start with that. That's e to the f of x times the derivative of the inside function, f prime of x. And we want g prime of 1. So we want e to the f of 1 times f prime. F prime is this graph. And f prime... Oh, I have to go back and fix that. Okay, hold on a second. F prime of 1, that's the negative 4. And so f of 1 is given to me in the stem of the problem. F of 1 is 2, e squared times negative 4. Let's go back up here and change this. F of 1 is given to me in the stem of the problem. F of 1 is 2, and so this needs to change to be 2. Okay, and so now we have our point and our slope, and so my equation would be y minus e squared equals negative 4e squared x minus 1. That would be the equation of the line that I have for 2a. I guess you could distribute there if you wanted, but I don't want to. That's a sufficient answer for us. Okay, that's 2A. What about 2B? 2B says on the interval for which G has a local max. Okay, so I'm going to need G prime for that because I want to set G prime equal to 0. So I want to know when this is equal to 0. Well, e to the is never equal to 0. So I don't have to worry about that thing even though it looks scary because that's never equal to 0. So when is f prime equal to 0? Well, they told me that f prime was equal to these places, equal to 0 at these places. So if I make a g prime sign chart and I put -1 and 3, let's take a look at the intervals. This, by the way, not only will never be 0, is always positive. So I've got a positive times whatever y value I have here. So to the left of -1, f prime is positive, so I have positive times positive. Between -1 and 3, f prime is negative, so I have negative times positive. And to the right of 3, f prime is positive, so I have positive times positive or positive. So I see that I have a max at x equals -1 because to the left of x equals -1, g prime is greater than 0, and to the right of x equals -1, g prime is less than 0. They also ask about, well, and the endpoints aren't included, and this would be a min, so that's my only max, and there's my justification. Okay, I guess I'm going to 2b. 2b, the only max is at -1. Okay, let's take a look at 2c. 2c says the second derivative is given by this interesting thing. Well, let's take a look at the second derivative. They say g double prime equals e to the f of x times f prime of x squared plus f double prime of x. And they say g double prime -1. Is this positive, negative, or 0? Is g double prime positive at -1, positive, negative, or 0? So g double prime of -1 would be e to the f of -1 times f prime of -1 plus f double prime of -1. All right, what do we know? Well, this is always positive. And then f prime at -1 is -4. -4 squared is 16. And now what about f double prime at -1? Well, yeah, I'm a little troubled by that because I want to say f double prime at -1 is the slope of f prime at -1. And so my slope at -1, yeah, I don't know what my slope is there. I know it's a negative number, but I don't know what negative number. I honestly don't think it's more negative than 16, but I feel a little uncomfortable about this. Let's see what we know. F prime of, oh, this is -1, not +1. This is 0. Okay, so this is a negative slope plus a negative, right? 0 plus a negative is negative, and negative times positive is negative. And so g double prime of -1 is negative. And there's my justification. Okay, part D. Find the average rate of change of g prime on the interval from 1 to 3. The average rate of change of g prime on 1 to 3. So we want g prime of 1 minus g prime, g prime of 3 minus g prime of 1 over 3 minus 1. G prime of 3 is, and remember we said that G prime was equal to e to the f of x, e to the f of x times f prime of x. So G prime of G prime of 3 is going to be e to the f of 3 times f prime of 3, and G prime of 1 is going to be e to the f of 1 times f prime of 1. Okay, so f prime is the graph given to us. F prime of 3 is 0. So I was worried that I didn't know f of 3, but 0 times e to the f of 3 is going to be 0. And f of 1, they tell me in the stem of the problem, is 2. And f prime of 1 is negative 4. And so then I end up with 0 minus a negative 4e squared over 2, which is 2e squared. I believe the answer for 2d is 2e squared. This is D. Okay, problem number 3. 3 says f is a piecewise function. F is defined as a square root of x plus 1 on 0 to 3, and then 5 minus x, a linear function, from 3 to 5. Okay, is f continuous at 3? Okay, so in order to be continuous, we need some information. We need to know that f of 3 exists. I see that 3 is included here. 3 plus 1 is 4. Square root of 4 is 2. So f of 3 equals 2. Good. Now, what about the limit as x approaches 3 of f of x? Does that exist? Well, in order for that to exist, the limit as x approaches 3 from the positive side should equal the limit as x approaches 3 from the negative side. So let's plug a 3 into this side now. 5 minus 3 is 2. So I get a 2 here as we approach from the positive side, and we plugged in a 3 here. We got 4, square root of 4 is 2. Yes, the limit is 2, and so f is continuous at x equals 3 because f of 3 equals the limit as x approaches 3 of f of x equals f as x approaches 3 of f. Okay, so there's part A. Part B says find the average value of f on the closed interval. So I want the average value of the given function, 0 to 5, of f of x dx. The problem with this is that I have two different functions here. I've got the square root function, and then I have that linear function with a negative slope from 0 to 5. And so I'm going to have to split this up into two integrals. I'm going to say 1/5 the integral from 0 to 3 of square root of x plus 1 dx plus the integral from 3 to 5 of 5 minus x dx. Okay, and I actually have to find that average value, so I need to do some antiderivatives. So integral of x plus 1 to the 1/2 is going to be 2/3 x plus 1 to the 3/2 And we want to evaluate that from 0 to 3. 0 to 3. If I plug in a 0, I get 1. 1 to the 3 halves is 1. 1 times 2/3 is 2/3. If I plug in a 3, 3 plus 1 is 4. Square root of 4 is 2. 2 to the third is 8. 8 times 2/3 is 16/3. So we want 14/3. That's this area, 14/3. Now let's do the area from 3 to 5 of 5 minus x dx. That would be 5x minus x squared over 2 from 3 to 5, which gives me 25 minus 25 halves minus 15 minus 9 halves. So 50 halves minus 25 halves is 25 halves. And then 30 halves minus 9 halves is 21 halves. And so I end up with 4 halves or 2. How convenient. 2 is 6/3. So 6/3 plus 14/3 is 20/3. So I have 20/3 times 1/5. I cancel, and I get 4/3. I get 4/3 is the average value of f on the interval. Yes, nice. Okay, part C, the last part of number 3, says, suppose g is defined in this other way. G equals k times square root of x plus 1 on 0 to 3, and mx plus 2 for 3x greater than, less than or equal to 5. Where k and m are constants, if g is differentiable, what are the values of k and m? Well, so remember our definition of differentiability has two parts to it. The first part is g is continuous at x equals 3. And to be continuous, we want g of 3 to equal the limit as x approaches 3 of g of x, which means the limit as x approaches 3 from the negative should equal the limit as x approaches 3 from the positive. So let's take a look at the value of these limits. We'll plug in a 3 here. 3 plus 1 is 4. Square root of 4 is 2, so I get 2k. And we'll plug in a 3 here, and I get 3m plus 2. So I know that the limit from the left should equal the limit from the right. Okay, this is also the value of g of 3. But what else do I know? I also know that if we want to say that g is differentiable, then we know A, B. We also know that the limit as x approaches 3 from the negative of g prime should equal the limit as x approaches 3 from the positive of g prime. So I need to take the derivative of each of these. Okay, so the derivative from the left, we've got k x plus 1 to the 1/2. I'll take the derivative there, and I'll have 1/2 k x plus 1 to the minus 1/2, which is the same as k over 2 square root x plus 1. And that should equal the derivative on the other side, which is m. Now, remember, this is the limit as x approaches 3, so I'm going to plug a 3 in there. 3 plus 1 is 4. Square root of 4 is 2. 2 times that 2, I get a 4 here. So now I have this equation, and I have this equation. Well, let's replace m with k over 4. So 2k equals k over 4 plus 2. I'm going to multiply everywhere by 4 to clear out the fraction. 8k equals k plus 8. And then I'll get 7k equals 8, and k equals 8 sevenths. K equals 8 sevenths. And then m equals k over 4, and so 8 sevenths divided by 4 is 2 sevenths. I end up with 2 sevenths for 3, and that's finding me the value of, oh, look at that, I got different numbers. All right, let's go back and check this. 2k, 3m plus 2, that's good. M equals k over 4, yes. 3m plus 2. Did I? Oh, ha, silly me. I did m plus 2, not 3m plus 2. So this will be a 3k. So when I subtract, I'm subtracting not 1k, but 3k. So this is 5k. So this is over 5. This is over 5. And this is over 5. Okay, so we get that k equals 8 fifths and m equals 2 fifths. Okay, so remember differentiability, we need continuous, and we need the limit of the slopes to be the same. Okay, so there's problem 3. Let's take a look at problem number 4 now. Problem number 4 says f is defined as a semicircle, 25 minus x squared, negative 5 to 5, and find f prime of x. Wow. Okay, f prime, 1 half, 25 minus x squared to the negative 1 half times negative 2x. And I guess you could cancel those if you wanted. And so you would have negative x over square root 25 minus x squared. But I would leave my answer like that for the AP, and this only for multiple choice. Okay, B. B says write the equation for the tangent line at x equals negative 3. So I need f of 3, and I need f prime of 3. Sorry, these are negative 3. I need a point, and I need a slope. So if I plug negative 3 in here, negative 3 times negative 3 is 9. 25 minus 9 is 16. Square root of 16 is 4. So I get a 4 here. And I need f prime of negative 3, so I'm going to plug my negative 3 in here. I have negative and negative 3. And then on the bottom, we said that this was equal to 4, and so we get 3/4. So y minus 4 equals 3/4 x plus 3. There's my tangent line equation, which is 4b. 4b. 4c. 4c says g is a function defined in this interesting piecewise manner. G equals f for negative 5 to 3, and g equals x plus 7 from negative 3, oops, that's negative 3, negative 3 to 5. Alrighty, and they say, is g continuous at negative 3? So in order for g to be continuous, we need the limit as x approaches negative 3 from the negative to equal the limit as x approaches negative 3 from the positive. So negative 3 from the negative means I'm plugging a negative 3 into the x's of f of x. And when I plugged in that negative 3, as I did in the last part, I got a 4, so this is 4. Now, what about the limit of the function from the other side? Negative 3 plus 7 equals 4. So, yes, G is continuous at x equals -3 because the limit as x approaches -3 from the negative side of G equals the limit as x approaches -3 from the positive side of G, which equals G of -3. Remember, G of -3 is the same as this limit. These values are the same according to our definition here. All right, so we've got, yes, we are continuous, and now we're taking a look at part D. Part D is an integral. They want us to find the value of the integral of x square root 25 minus x squared dx. I see a function and someone else's derivative. So to me, this is a u sub where u is 25 minus x squared. Therefore, du over -2 equals x dx. There's my x dx, that's du over -2. And here's my u, so I have the integral of the square root of u du over -2. And so I'm going to pull out that -1/2, and I'm going to have u to the 1/2 du. The antiderivative of u to the 1/2 is 2/3 u to the 3/2 times the -1/2 that was already out there. And so I get -1/3 u to the 3/2. Now we're asked to do a definite integral here from 0 to 5. 0 to 5. So let's come back up here and say -1/3 25 minus, I want to do this with u bounds rather than rewrite that. So let's plug in our x values here. If I plug in a 0, I get 25 minus 0 is 25. So this is -1/3 u to the 3/2. This is 25. And if I plug in a 5 over here, 25 minus 25 is 0. I can flip these, can't I, and pull out that negative. So I'm going to get 1/3 u to the 3/2, 0 to 25, which is going to be 125 over 3 minus 0. So there's my answer, 125 over 3. Great, there's problem number 4. Pretty straightforward. That felt kind of not unreasonable. Problem number 5. 5 says r of t represents speed. Okay. 120, 1 minus e to the -10t squared. Thank goodness there's a calculator available for me on this problem. This is speed. Okay, we know this is the absolute value of velocity. We also know that if we integrate this, we get total distance traveled. If you integrate speed, you get total distance traveled. If you integrate velocity, you get net change in position. Okay, so what does it say here? In kilometers per hour, which the car travels along a straight road. The number of liters of gasoline used by the car, x kilometers, is modeled by g of x equals 0.05x, 1 minus e to the -x over 2. And these are, I plug in kilometers and out come gallons. Okay, so I've got these two different functions. Kilometers goes into this one, gallons comes out. And this one, I plug in a time, and out comes kilometers per hour. Okay, let's be careful with this one, people. Part A, how many kilometers does the car travel in 2 hours? Okay, so if I integrate r of t dt from 0 to 2, I'll get that value. This is all done on the calculator. I'm not going to take the time to type it into the calculator because I've done that enough on previous videos. I ended up with 206.370 kilometers traveled during the first 2 hours, or hours 0 to 2. There's part A, nice and gentle. Okay, what about part B? Find the rate of change with respect to time of the number of liters of gas used by the car at t equals 2 hours. Notice t equals 2 hours. The input is time, but the input on our gallons function is not time, it's kilometers. So part of me says, well, no problem, I just need to find g prime of something. G prime of what? G prime of the time equals 2. Time equals 2. But this is supposed to be kilometers. So I'm going to need to find how many kilometers I've traveled at 2 hours. Oh, I know how many kilometers I've traveled at 2 hours. That's this number. Oh, so I'm looking for here g prime of 206.370. Okay, so now what information do I need to find g prime? I need, and I have to think about this using units, right? Because I'm looking here then, g prime would be gallons per hour. That's what g prime is going to be, gallons per hour. Oh, I'm sorry, are these liters or gallons? Kilometers, number of liters. Sorry, why did they call it g of x then? These are liters. Okay, so we've got liters per hour. But this function is, this function is, this function g is liters per kilometer. And so I'm going to need to multiply by kilometers per hour to get liters per hour. Okay, so this is dx dt, which equals v of t, and the absolute value of v is that speed function r of t. Okay, so I'm going to take r of t and multiply it by g. But I want, the time is 2. Wow, there's a lot going on here. So let's do this. We want g, g prime, and that's going to be 0.05 times r of t. And how did I know that? Wait, let's back it up. G of 206.370. We know this is how many kilometers we traveled in 2 hours. We want to know how many liters of petrol we've used after we've traveled that many kilometers. And so when I plug this number into my original g function, I get, I kind of want to check just to be sure. Point O g of x. 0.05 x times to the negative 0.5x. Okay, so if I plug in 206.370 into this function, I get something that I wasn't quite expecting. So, okay, I got to be thinking about this one. Liters per kilometer. I want the rate of change when t indicate units of measure. Thanks. I want g prime. I want liters per hour, but that's liters per kilometer. That's g prime of x times kilometers per hour. That's r of t. So I want g prime 06.370 times r of 2. Wow, that took a little while. So yeah, again, units are really important. I want liters per hour. I've got liters when I plug in kilometers. I plug in kilometers, I get out liters. But I needed liters per kilometer. Liters per kilometer comes when I take the derivative of g. The derivative of g prime. G prime is liters per kilometer. Now, r of t is the speed at 2. Do I want the speed at 2? I thought what I wanted here, oh yeah, kilometers per hour. I want the speed at 2. So, and that's kilometers per hour, and that's going to give me liters per hour. Okay, so let's compute these. I need in y2 n derive of y1 comma x, and then I also need the r function, and r is 120 parentheses 1 minus e to the negative 10x squared. Okay, so I come over here and I plug in 206.370, and I want to know what the derivative is. That derivative is equal to 0.05, and r of 2, let's plug in a 2 over here, enter, r of 2 is 120. So 1 over 20 times 120 is 6. Wow, that turned out to be 6. This is 6 liters per hour. Yikes. Talk about, wow. I'm glad we pay attention to units. That took a long time. You know, if you're pressed for time, you might want to skip a problem like this. I just want to tell you the story about Sarah, who came back from the AP exam her year and said, Mr. Kukla, I'm scared. I had to leave one of the free response completely blank. I freaked out. Oh my gosh, I'm going to fail. She ended up with a 5 on the exam. So, yes, it's good if you can write stuff down, but no, don't really freak out and stress about these. In fact, I think worrying about this problem and stressing about not knowing how to do it is going to cost you more points than just skipping it and moving on. So you might consider that alternative. Okay, and that was part B. Oh my goodness, what a part B. And then part C, how many liters of gas have been used by the car when it reaches a speed of 80? Speed of 80 kilometers per hour. and we want to know how many liters of gas have been used. Well, when I think about integrating, um, when I think about if I integrate, it's time for some more thinking again. Okay, let's start with when do we reach that speed? When does R of t equal 80? Okay, so I go over to my graphing calculator and I graph the line y equals 80, and I'm going to turn off these gas functions, and I'm going to go on a window that I have no idea. So I'm going to go 0 to 10, and my y values, my y values have to include at least 80, so my y min will be 0 because I can't go backwards, and I'm going to put in 120 here in steps of 10. So let's see what this graph looks like. That's pretty steep. And then we've got second calculate intersect, and enter, enter, enter. So we've got x equals 0.33145321. So this is how many kilometers I've traveled to get to that speed. Okay, now what are we looking for? How much gas has been used to that point? Wait a second. This is not x. This is a time. That's a time. I need to integrate a rate t from 0 to 0.33145321 to get kilometers. Wow, I really have to think about this stuff. Okay, so I now integrate, math integral, and I'm integrating what I have in y3, comma x, comma 0, comma 0.33145321, and I end up with 10.794 kilometers. Finally, I have something that I can plug into the g function. I have g of 10.794. Okay, so if we go back to our g function, which was the first function I typed in, and do 10.794, I end up with, we want to turn those other functions back on. Table, I get 0.537 liters. Wow. So to get to 80 miles an hour, I had to set the rate equal to 80. I found out that took a certain amount of time, 0.33 hours. Then I needed to integrate that rate to find out how many kilometers had been traveled. And then I had to take those kilometers and plug them into the gas function to get 0.537 liters of gas were used by the time we got to 80 kilometers. Woof. Okay, that was a lot of work. How about number 6? Number 6 says f equals 1 minus 2 sine x for x less than or equal to 0, and e to the negative 4x for x greater than 0. Show that f is continuous at x equals 0, so we know that f equals 0 should be the limit as x approaches 0 from the positive side of f, which should equal the limit as x approaches 0 from the negative side of f. Okay, so let's plug a 0 into each of these, and we get a 0 here is 0. So I get 1 minus 0, or 1. And that should equal, oh, that's this one over here, 1 minus 0, or 1. Now if I plug in a 0 here, e to the 0 is 1. So f of 0 equals that, and therefore, since f of 0 equals 1, and the limit as x approaches 0 of f equals 1, f is continuous at x equals 0. Great! That's part A. What about part B? Part B says, for x not equal to 0, express f prime of x as a piecewise defined function. Find the value of x for which f prime equals negative 1. All right, well, let's take the derivative of this f function. F prime is going to be the derivative of negative 2 sine is negative 2 cosine, and that's going to be good for x values less than 0. And then the derivative of e to the minus 4x is minus 4 e to the minus 4x, and that's good for x greater than 0. And now we're asked to consider when f prime equals negative 3. Well, let's think about this for a second. I want to set each of these pieces equal to negative 3. Negative 3 equals negative 2 cosine x. Divide both sides by negative 2. I get 3/2 equals cosine x. Is cosine ever going to be equal to 1.5? No, the highest cosine goes is 1. So nothing's happening on that side. What about on the other side? Negative 3 equals negative 4 e to the negative 4x. I get 3/4 equals e to the negative 4x. I take the ln of both sides, and so I get x equals ln of 3/4 divided by negative 4. That's going to be the location of where this function is equal to, where f prime is equal to negative 3. Do they ask me to justify anything? No, just find the value. So there's my answer. Don't box things in. It's a really bad habit. I don't know what that's going to be like on the safety exam. Because it seems like all you'll be doing is typing things into boxes. Okay, and find the average value of f on negative 1 to 1. So we want the average value, which is 1 over 1 minus a negative 1, integral negative 1 to 1 of f of x dx. But be careful, because this f comes in two pieces, and so when I evaluate this integral, it's not integrating this the whole time, or this the whole time, but instead I need the integral from negative 1 to 0 of 1 minus 2 sine x dx plus the integral from 0 to 1 of e to the minus 4x dx. And this problem is without calculator, so I better get to it. I need the antiderivative of x, of 1 is x. The antiderivative of negative 2 sine of x is plus 2 cosine x. And we want to evaluate that from negative 1 to 0. That makes me feel so uncomfortable, plugging in a value like that into that function. Okay, I guess I'm leaving trig evaluation. Plus, and don't forget we have the 1 half. The antiderivative of this is e to the negative 4x over negative 4, and we want to go from 0 to 1 there. Okay, so let's take a look at each of these pieces. We plug in a 0. We plug in a 0. Cosine of 0 is 1. So I get 0 plus 2 minus, I plug in a negative 1. Negative 1 plus 2 cosine negative 1. This is the thing that was bothering me. Usually they put me in a position where I can evaluate this, but I can't evaluate this without a calculator. And my understanding is this problem is without a calculator. Let me just confirm that. 6 without calculator. That feels awkward and uncomfortable. So, plus, I plug in a 1, I get negative 1/4 e to the negative 4, minus, and I plug in a 0, e to the 0 is 1, so I get minus 1/4 here. And I'd probably leave my answer like that, but, because we probably ought to tidy things up, let's see what we can do here. Minus a minus 1/4 is plus 1/4, and then minus a minus 1, so I have 3 plus 1/4 is 13/4, and then here minus 2 cosine negative 1 minus e to the negative 4th over 4, and then I want to have that 1/2 times each of those. And so I'll end up then with 13/2 minus cosine of negative 1 minus e to the negative 4th over 8. Yeah, okay, that's what I got last time. That's part C, and I believe that's it for number 6. Number 6, part C, all we have left to do is problem number 7. Let's take a look at problem number 7 then. 7 says f is a continuous function defined on negative 4 to 6 with closed interval. F consists of a line segment and a curve that is tangent to the x-axis at x equals 3. As shown in the graph above, that's a graph of f, not f prime. On the interval, f is twice differentiable, and f double prime is greater than 0 on 0 to 6. Okay, yes, I see f is concave up, and so that makes sense to me. Okay, part A, is f differentiable at x equals 0? No, f is not differentiable at x equals 0 because while f is continuous at x equals 0, the limit as x approaches 0 from the negative side of f prime does not equal the limit as x approaches 0 from the positive side of f prime. The limit of the slopes are not the same from both sides, and that shows up as this point. See that point there? The limit of the slopes here is positive, the limit of the slopes here is negative, the limit of the slopes is not the same from both sides, and so f is not differentiable at x equals 0. Okay, B. For how many values A on negative 4 to 6 open interval is the average rate of change of f, f of 6 minus f of a over 6 minus a equal to 0? Oh. Okay. That's what I'm thinking about right now. Now, how do we put that into action? I think I have to think about that one for a second. So let's think. Well, in this case, I'm going to multiply both sides by 6 minus a. So these cancel, and then I have 0 equals f of 6 minus f of a. And so f of 6 equals f of a. So how many times is the y value of 6 the same as the y value any other place? Well, the y value at 6 is 1. And I see that on the interval from, and they asked me to consider the interval, um, they asked me to consider the interval from -4. And so I see a y value of 1 here and a y value of 1 over here. I see 2 times when the y value would be 1 um, equals 1, and f crosses y equals 1 a total of 3 times. So x equals a occurs in 2 locations other than x equals 6. Okay, there's part B. Part B. Part C. Is there a value A closed on one end but open on the other? What the hell? Applied, mean value theorem, that's why, because they gave me the closure on the other one. Applied on the interval from A, this is such a weird question. So we want A to 6, MVT equals 0. Is that what I understand here? Is there a value? No, that was the last problem. Is there a value for which the MVT applied on that interval guarantees from A to 6 F prime equals 1/3? Okay, so F prime of C equals F of B minus F of A over B minus A. So I think it's important to, stay focused and think, well, what does this mean? And if I'm doing MVT, I should probably write down MVT. It says F prime equals 1/3. So I'm wondering, is there a place where F prime equals 1/3 given this A and B value? So F of 6 minus F of A over 6 minus A. Well, we know that F of 6 is 1, so I can put a 1 in here. And I'm going to multiply both sides by 6 minus A. And so I get 6 minus A over 3 equals 1 minus F of A. If I multiply both sides by 3, I get 6 minus A equals 3 minus 3F of A. I subtract 3 from both sides. I get 3 minus A equals -3 F of A. Well, where am I going now? I feel like I've done a whole bunch of stuff, but I'm not sure where I'm going with this yet. I'm sort of stuck in algebra land. Why don't I go back to thinking land? Okay. MVT says the slope at a point equals the average rate of change, or the slope of the secant. So let's think about that. Slope at a point equals the slope of the secant from some point A to 6. And that's asking me, is it possible for me to have a slope of 1/3 for this secant slope from A to 6? All right. So, oh, that's very interesting. You know, what did they tell us in the stem of the problem? They said there's a horizontal tangent at x equals 3. So I know there's an ordered pair of 3, 0. I know there's an ordered pair of 6, 1. So let's try that. So 1 minus 0 over 6 minus 3. Well, 1/3. Why, yes, there is a place on, yes, MVT works on 3 to 6 because the slope of the secant on 3 to 6 equals 1/3 or f prime at some point. Great, there's part C. Okay, finally part D. Part D says the function g is defined in this interesting way. 0 to x of f of t dt. On what intervals from -4 to 6 is g concave up? Okay, so if I want g concave up, I'm thinking g prime is equal to f, because I take the derivative of both sides. And so g double prime equals f prime. Well, I don't have an f prime graph, but I do have an f graph. And if I want to know when g is concave up, that would be g prime increasing. So I want to know when f is increasing. Well, I see f equals g prime is increasing on -4 to 0, union 3 to 6. So g is concave up on those intervals. Okay, and that's us being done with this packet. I hope this was helpful. I'm sorry I was sleepy when I started it. Take a second look at that gasoline problem. Oh my goodness. I think I still have nightmares and flashbacks about that one.